The objective today is to describe how a network interface card, aka NIC, works. So we'll first start by talking about how this is just another component on the motherboard. Then I'm going to give you like this wow thing, and then you might ask why. After that, we'll talk about different medium types that data can come into. And then we'll talk about butchers and blocked ports, NIC and security, how security is related to the network interface card. Then we need a review MAC addresses, talk about their relation to network interface cards. After that, it's a fun topic of MAC spoofing. Not very much on that though. And we'll just finish the lesson by having you describe how these network interface cards work. So this is the first part in our exploration of network interfaces cards. I have two parts to this lesson because I really got into this topic for some reason. This will give you a good general overview of what's happening inside this nifty device. And then part two, we're going to rehash the basics in part two and just give you additional details and vocabulary for you to use when you're talking about how NICs operate. So a network interface card is another component on the motherboard, unless we are talking cell phones. Then it's on the SoC, the SoC, the system on a chip. We've gone through a lesson like this before where I explained how the processor chips work on a cell phone. As you can imagine, everything is crammed inside of a cell phone, so that is actually including the concept of a network interface card, and this thing connects to an antenna that the cell phone will have if that cell phone has the ability to connect to Wi-Fi. And if you haven't watched that lesson, definitely give it a look. I think I'm even a bit of a comedian in that one when I'm saying you get extra credit for busting your cell phone and pulling out that antenna. And why, you may wonder? Did I put a picture of two pairs of socks here? Because that's not the kind of sock I'm talking about. I'm talking about a system on the chip. But for the rest of this lesson, let's not imagine we're talking about a network interface on a cell phone. Let's imagine we're talking about just a good old-fashioned one on a motherboard inside of a desktop computer. And not only do you want to describe how these things operate, but you might need to switch one out someday. There are times when you'll need more than one network interface card as well. And of course, network interface cards are hardware, and hardware goes bad sometimes or breaks. And so it's nice for you to be able to switch one out without replacing like the whole thing, especially if you have like a nice rig, a nice PC master race gaming thing set up. If the NIC goes bad on that, you don't want to have wasted all that money. You just want to switch it out. So the types of NICs are as varied as the mediums used to create networks. Remember mediums, when I say that, I could talk about like a copper wire as a medium for transferring ones and zeros. I could talk about a radio signal or radio wave, or maybe a light. If we're talking fiber optics, we're talking about ones and zeros coming in the format of light. So not only do you have different ports on network interface cards, but you just have different interfaces on the NIC itself to connect them to the motherboard. So this is a PCI interface. This connects to something, that fits these pins. Over here, that is a different looking one. So again, different network interface cards depending on the device we're talking about. And this one is the network interface card for a laptop, and I actually have one right here. I know you're looking at a camera that's probably not the best view to look through, but these little things are little, and this is the antenna connection that the network interface card makes. So the signals come from this wire, and then of course it connects to these pins which go into the computer, so the computer can understand the thing that you're trying to communicate with. So this Think Right Share is really wide open. I want you to just tell me what you see in this picture. What are the terms that you don't know yet? I'm just amazed by this network interface card, how it's like a mini computer within a computer. I mean, you have a processor here. This is called the bus connectors, something called jumpers. Again, part of the Think Right Share here is what are the terms you don't know yet? Do you know what RJ45 is? AUI? I'll give you one term though, BNC. This is like a coaxial cable, and it just blows my mind that this cable is plugged into this port, and the ones and zeros are coming from that copper wire going through this mini little PCB board that's connected to a larger motherboard, a larger PCB board, and so the ones and zeros here are turned into ones and zeros that are on this interface. So the networking mediums I'd like you to remember are copper, fiber optic, and radio waves. These are the big ones for network interface cards. And your think, write, share here is use your imagination here. What other mediums could exist, and what other way can we send ones and zeros? I'm asking for a little creativity there. So the NIC is the hardware thing, and the driver is the software thing. You need a driver to make the NIC work. What are these things actually doing? Well, when bits come in, they are organized into what's called frames, and within the frame you have a destination address, so they know where the data will be sent. At this time, the header of the frame is removed because it is no longer necessary, and the rest of the data is sent to the network protocol that the data happens to be using. So ones and zeros coming in from here, going through the network interface card, it's then cut up into the different parts that the computer understands. So those parts, next up on the butcher assembly line, those parts are sent to what's called the network protocol, and whatever protocol is being used, the computer will then do something else with those bits. To learn more about network protocols, you can look at a list of them on Wikipedia here. Let me make that bigger for you. We're not just talking about internet protocols or routing protocols, but other things you might not think of very often, like the Bluetooth protocol. TCP is a very popular one, and we've studied that in class before. If something comes into your network interface card that's a TCP protocol, well, the computer will know what to do with it. Alright, so now that the data has come through to a specific network protocol, we're in that area where if you've closed or blocked ports, the data won't move forward if you haven't given it the green light, essentially. And how do you give it a green light? Well, let's take something like the HTTP protocol. That goes through this handshake where first the server that you're communicating with has agreed to synchronize with you. So a port has opened up for HTTP. We're talking about port 80. This port has opened up, and the computer is literally expecting something to come in. So when something comes and says, I'm ready to go through that port, the computer accepts it. So it goes through because you initiated the connection. If you've blocked a port or you didn't initiate data to come in through a particular port, then the computer might not accept it, and like it says right here, it'll just stop. And let me do a quick note on ports here. It's probably worth explaining that when you connect to a server on port 80, the communication back to your computer may not well be on port 80, but rather a random high number port is typically chosen and used for the connection. So once I've gone through port 80, I could be on port 65,000, and then that's a bit of a security thing. Since it's random, only the computers that initiated the connection should know what port we're going back and forth on. And if you're really enjoying the security aspect of this network interface card lesson, I suggest you go do some extra research, like on support.microsoft.com. They will teach you interesting things like how to block specific network protocols and ports using IPsec. I will have an IPsec Fun with Wikipedia video coming out soon, but IPsec is basically this framework, a security framework, so something you can use to help protect yourself. And this website is just great because you can also learn about other things. The Windows registry is an interesting thing to study. And this site does a good job at breaking down some details. If you take the like CompTIA A+ test, you might find questions about the Windows registry on that test or that certification. This is just a good, interesting website to learn some super technical details. The scope of this lesson will not cover this stuff, but I thought I should at least introduce you to it. Okay, let's try to do a prediction here. And this question may seem a little bit confusing. What I'm asking you to do is imagine you have this network interface card that has both a wired port, so you've plugged in a Cat5 cable, and let's say it also has a connection to an antenna, so this network interface card can also communicate through Wi-Fi. When you go to send something out, how does the network interface card know whether to use the wire or the radio waves? Now, did you actually do that? Did you make a prediction? I don't want to tell you the answer until you've made the prediction. So pause here. How does the network interface card determine which medium to use? And here's a surprise that maybe is not a surprise. The NIC doesn't decide anything. You, the user, do. So when you plug in like when I plug in a cable into my laptop, after it's been on Wi-Fi, it might automatically switch to the cable. Maybe I have that configuration in my settings, or maybe I go to my connection. I take my mouse and go to the bottom of the screen and click Internet Connections, and then I can choose from there whether I'm using Wi-Fi or the wire. So the network interface card converts those bits into whatever medium it needs to communicate with the networked device that we're talking about. As a quick review, what is the difference between a packet and a frame? And use the following picture to help you. So right here I have my network protocol. And inside that protocol is just the data. So in this case, I'm just creating an echo request. So the data says to the computer, please, repeat right back to me. And this is the source IP and the destination IP. So I'm here sending the data to here. This packet is inside this frame. So the frame has a CRC, which is nice. It's an error check. And also there's a frame header, which is similar to this header inside of the network protocol. It is a destination MAC address and a source MAC address. And the question is, what's the difference between a packet and a frame? And this is for incoming bits, right? So I just got the picture I requested off the internet. The frame gets chopped off by the network interface card, and this gets sent over to or through my computer. It's just the opposite when we're talking about bits being transmitted out. So if I have a picture that I'm sending to somebody, here's the picture. I'm going to identify my IP and then the destination's IP. I'll put that in the network interface card. It throws a MAC address on it and sends it on its way. Okay, so another kind of tricky question like before, surprising but not surprising maybe. Who creates the MAC address on your computer? Because remember, you can always change your IP address, and some IP addresses change automatically. As long as you are following the rules of RFC 1918, you are allowed to change your IP address. To answer that question, the manufacturers, think of M for manufacturers, though MAC stands for media, not manufacturer, but the manufacturers of the NICs, there we go, I had a typo, of the NICs, no matter how big or small that network interface card is, it's the manufacturer who creates this MAC or physical address. And they have their own rules to play by as a business. They know these rules. But the interesting thing I found out is you could actually spoof a MAC. I'm not going to teach you how. One of the biggest reasons I don't want to start changing MAC addresses in class is because if there are two MAC addresses on the network, it's not going to work properly. And that's why these are stored on the network interface card's ROM. This is read-only memory. MAC's not supposed to change, but since nothing is impossible in computer science, there are always ways you can spoof a MAC. So there are two parts to every MAC number. The first 24 bits are the manufacturer's IDs. And this is called OUI for Organizationally Unique Identifier. And the second is basically the serial number of that the manufacturer created of that device, of that thing that you have. So MAC, Media Access Control Address. So a MAC address is made up of a total of 48 bits, and these are usually displayed to us in 12 hexadigits. So 12 being like, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 48 bits makes 6 bytes. You see how this is 6 bytes? So 0 is, so we have 1 byte here, 1 is 2, and then 3, 4, 5, 6. So a total of 6 bytes. Do the math if you think I'm not doing this right. For students who took computer science, they know that a 0x just signifies that this is in the hexadecimal format. So if we go back up here, C00A0, like A is a number in hexadecimal, and then this is CC. If we go up to this other one, the physical address is 001B, 2F. So this is 48 bits. Hey, don't worry about this other stuff. This was for another lesson, but I just like this chart. So you can wrap your mind around how large the MAC address is compared to your IPv4 address. But we are moving to IPv6 addressing, and we need to do that as soon as possible because of all these little IoT devices. So I'm showing you these same words to bring it home to you, that the manufacturers create the MAC address. So inside the server is a MAC address for that server. Inside of a thermostat that connects to an internet or connects to a network, since it has a network interface card in it, you can inside of an IoT thermostat right here, since it has a NIC in it, it will also have a MAC address. So for those of you who haven't watched my networking in general video, I highly recommend you do that, because what I'm saying here is, remember the zap video I did about machines listening. So if you're listening for the right kind of zaps or electricity that is saying your name, this will make the lesson a little more understandable to you. Especially for Wi-Fi, because the Wi-Fi routers are like hubs. They're just throwing out the ones and zeros into the air. They're broadcasting this out into the air, and then the network interface card's job is to listen to see if those ones and zeros are meant for that particular computer. Now there's a total of 3 ways the network interface card will listen to an inbound zap. The first thing it will do is it will see if there's an exact match for the MAC address. Now if there's a broadcast address, so if it sees all Fs, all computers are supposed to listen to that broadcast address. Or if your network interface card for some reason is set to promiscuous mode, it will also begin listening to those zaps, those ones and zeros. So more details on that later. I just wanted to end the lesson with you knowing about that. For now, this is just basically how this little nifty device works. So at the end of the lesson, let's think about the character traits that make people good global citizens. Which one of these traits can be connected to our lesson today? And when you're done with that, here's your DOL. Pretty simple. Describe how a network interface card works, and use this word bank extra credit if you can use all 8 words in your description on how the NICs work.